January 1965. A special military truck is rolling through the Kazakh steppe, carrying a very special kind of cargo, a nuclear charge, a hefty explosive device 3 feet in diameter and 10 feet tall. They'd been preparing for this run and what would come after it for a long time, waited for the right day with the right conditions until the weathermen finally gave the green light. And now the truck comes to a halt, and the nuclear charge is gently, slowly lifted out to then be placed into a hole that had been drilled in advance. It takes a few hours. The well goes down as deep as 584 feet, but the bomb still makes it to the bottom. And that's when the countdown to the next morning begins. Time drags on slowly, inching closer to the moment of the blast. And finally, only 5 seconds remain. 4, 3, 2, 1. At 5:59 a.m. Greenwich time, the charge went off. The blast had a yield of about 170 kilotons, which was 8 times more powerful than the Hiroshima explosion in August 1945. The roar was absolutely deafening. 2.5 seconds after detonation, a cloud of searing hot gas started to form, and 5 minutes later it had climbed to 15,750 feet. Besides gas, the explosion threw 10.3 million tons of soil up to 3,117 feet and scattered it into dust. That's how a giant crater came to be, 1,410 feet across and 328 feet deep. Despite how massive the explosion was, not many people have heard about it, and even fewer know that it actually created a one-of-a-kind lake. Why did they even do it? We'll find out in a sec, but first, coffee. Just an unobtrusive reminder to do that thing under the video in case you forget. So the Soviet nuclear test called Project Chagan was carried out in January 1965 at the Semipalatinsk test site in Kazakhstan. It was part of the Nuclear Explosions for the National Economy program, which aimed to find peaceful and economically useful ways to use nuclear weapons. The place wasn't chosen by chance. A nuclear testing site had to be set up as far from people as possible, basically in the middle of nowhere. A good spot was found in Kazakhstan. Barren steppe, the nearest town, Semipalatinsk, now called Semai, was 80 miles away. Since this kind of experiment was the first of its kind in the USSR, the scientists had to meet special demands. The main one, the amount of radioactive residue released in the explosion, had to be extremely low because along with the soil, radioactive decay products would also be thrown to the surface. Just a reminder, this was 1965 and people already had a pretty good idea of what nuclear bombs could do. But even on the test site itself, they picked a special spot, the dry riverbed of the Chagan River, which the Soviet Union hoped to fill with a newly formed lake by partially diverting water from the river. And they actually did manage to create that lake. I've never seen such a beautiful sight from a nuclear blast before, even though I'd witnessed plenty of airbursts, recalled Ivan Turchin, the project leader. You'd probably have to really love nuclear explosions to admire their beauty, but that's not the point here. Around 50 days after the detonation, by which time the dust cloud had settled, work kicked off at the site. A channel needed to be dug and connected to the crater to let in the floodwaters. Time was tight. The explosion had happened in January and it was already March, which meant the flood season was almost here. To dig the canal, they used heavy machinery and regular non-nuclear explosions. A few hundred people were involved in the work, though the exact number isn't clear. Some say it was 180 people, others say 300, but all of them worked really hard, and that's why they made it in time. When the flood hit, all that was left to do was blow up the barrier between the river and the canal, and the waters of the Chagan River rushed into the crater, and rushed fast. No less than 528,000 gallons of water per minute. As a result, the crater was filling up even faster than expected. By the third day, the volume of water in the crater had reached 792 million gallons, and a few days later it hit 2 billion gallons. On top of that, a separate reservoir nearby formed with a volume of 3 billion gallons. Maybe you're wondering, but why? What's the point? It's simple. Soviet scientists wanted to figure out how to create reservoirs quickly. Their idea was that craters from nuclear explosions could make really handy water reservoirs, and building those was really important for Central Asia. You know, dry, hot climate, rivers drying up in the summer, constant water shortages. In such reservoirs created by nuclear explosions, spring runoff would accumulate in a small evaporation mirror, and the melted bottom would help store this water for irrigation, livestock, drinking water, even for bathing. Around 40 artificial ponds with a combined volume of 32 to 37 billion gallons were planned for Kazakhstan. Everything would be fine, but the scientists didn't pay enough attention to the radiation problems. Today, even the thought of nuclear explosions in your own country seems crazy, but back in the 60s, the scientific community thought it was a great idea. Just think about the slogan of that project: peaceful atom in every home. After the creation of nuclear weapons, the USSR joined the Nuclear Club and started developing more powerful atomic bombs, building nuclear submarines, and other military means to ensure the country's security. But even in the early days of these projects, Soviet scientists suggested to the leadership to expand the scope of research and, in particular, to take a closer look at the use of the peaceful atom. Only Joseph Stalin believed that other projects should be postponed until the successful test of the first nuclear weapon. As a result, the first explosion at the Semipalatinsk test site took place on August 29, 1949. This meant that the U.S. lost its monopoly on nuclear weapons, and Soviet scientists could finally focus on other ways to use atomic energy. After working out the theory and receiving the corresponding report, Stalin signed a special decree on May 16, 1950, on research, design, and experimental work on the use of atomic energy for peaceful purposes. By the way, this decree actually marked the beginning of the work on the creation of the world's first nuclear power plant in Obninsk. But aside from its construction, the document also specifically mentioned the need to explore the possibilities of conducting explosive work using nuclear charges. In the end, after a series of events and trials, the Nuclear Explosions for the National Economy program was launched. I already mentioned it today. By the way, here's a photo of the biggest explosion out of the 124 conducted by the Soviet Union. Anyway, let's get back to our lake. In a Soviet documentary film about the creation of the atomic lake, the narrator said that 50 days after the explosion, the radiation levels no longer posed a threat to anyone. At least soil samples were taken from the areas and the dust trail, and they showed that the radiation had dropped to safe levels. Who's going to argue with such facts? Plus, at different times from various spots of the experimental reservoir, water samples were also taken. They too turned out to be completely safe for humans, suitable for irrigating fields and watering livestock. In 1966, the newspaper Izvestia even wrote that a beautiful Lake Chagan had been created with clear, transparent water. The area had transformed. People trusted the lake so much that one person even decided to go swimming in it. That person was the Minister of Machine Engineering of the USSR, Efim Slavsky, who was nearly 70 years old at the time. What's interesting is that the minister lived to be 93 and, according to his relatives, never complained about his health. Well, since the minister was fine, they could have tested it on other forms of life. After water appeared in the crater, scientists tried to populate the created body of water with different organisms, and I mean really different ones. For example, they released 36 different species of fish into the lake, including piranhas. They specifically brought them in from the Amazon for this. Besides the fish, they tested the lake with 27 species of mollusks, 32 species of amphibians, 11 species of reptiles, 8 species of mammals, 42 species of invertebrates, and nearly 150 species of aquatic plants. They even set up a biological research station here for all these checks, but none of the organisms managed to settle. I mean, there were species that survived, but with each new generation they mutated, becoming something only vaguely similar to their original form. After some time, 90% of the organisms perished. It seems that only the carp managed to survive, and they still live in the atomic lake. But the experiments on animals and plants gave such a shocking result that the project was shut down. In 1974, the people who'd been working at the site of the nuclear explosion were taken away. Only after that, it became clear what exactly the scientists had done when trying to create a reservoir using a nuclear explosion. On the shores of the atomic lake, such a huge amount of radioactive fallout fell that even 60 years after the explosion, it remains the most contaminated place on the Semipalatinsk test site. Naturally, due to the high radiation levels, the atomic lake was never handed over for public use. According to the senior foreman who supervised the drilling work, many of his subordinates died much earlier than expected. This was despite the fact that most of them started the project when they were young and healthy. Overall, this has been and remains a huge public health issue, but until 1956, no research was done on the impact of nuclear tests on the local population, not even on those living near the test site. So there are no statistical data regarding the acute and long-term effects of the tests. What is known is that numerous negative health effects from radiation exposure near the site were often described in the literature. This is true for the effects of all nuclear explosions at the site in general, but the fact remains. The worst part is, they found traces of plutonium-239 in the same area, and its half-life is 240,000 years. In the end, they wanted to bring life-giving water, which was supposed to transform the dry land, but instead they got the opposite effect. As you remember, the plan was that in the spring, when the snow was melting, the sinkhole was supposed to fill with water that would last the entire dry summer for watering livestock. Partially, that's what happened. The sinkhole filled up with water, and a large lake 3 to 6 feet deep formed nearby. However, this flooded area dried up in the summer, and no one drank from the artificial sinkhole. No one even wanted to get close to it. As a result, the lake created by the nuclear explosion started to terrify the locals, and the Chagan River found a new course, flowing without touching the crater. People who visited the lake shortly after it was created say it made a horrifying impression, not because of radiation, since you can't see that, but the water's surface was lifeless and black, and all around were grim mounds of dirt. From the description, it makes me think of something like Mordor. But there were also more long-term effects besides the lack of water and the locals' fear. The bomb created a low-level radioactive trail that reached Japan and kicked up dust high into the atmosphere. The explosion also changed the local geology, turning the mountain rocks into glass-like and metamorphic ones, as they were exposed to high temperatures. There's also information that the explosion cloud covered the area of 11 settlements with a total population of 2,000 people. The estimated thyroid radiation doses for those living in the most contaminated areas in the first 1.5 years after the explosion were over 14 rem. To give you an idea, the maximum radiation dose is 0.5 rem per year or 5 rem over 50 years, and here it was 14 right away. Most likely, the people who suffered the most were those who worked directly in the contaminated zone. As I mentioned earlier, some sources say there were up to 300 of them. Unfortunately, the project was probably too secret to know the exact numbers. However, we do know some other data. From 1971 to 1988, the Soviet Union carried out 124 peaceful nuclear explosions as part of a government program. The last one took place in the Arkhangelsk region on September 6, 1988, as part of the Rubin project. They detonated an 8.5 kiloton charge 28 feet underground to study seismic activity of the Earth, and all 124 of these explosions were part of unique research that had no analogs in terms of scientific and practical significance. In fact, maybe they still don't. In the U.S., a similar program was launched in 1957, and in 16 years, they carried out 27 explosions for peaceful purposes. At the same time, they were probably a lot dirtier than the Soviet ones in terms of radioactive emissions. When it comes to the goals of peaceful Soviet explosions, they were quite diverse. Getting water, extracting oil, digging up earth, mining for minerals, all of this was part of the people's economy. Bashkortostan, Yakutia, Komi, Kalmykia, Khanty-Mansi Autonomous Okrug, Irkutsk, Kemerovo, and Ivanovo regions, Krasnoyarsk Krai, all these territories subjected to peaceful bombings. And often, these bombings were successful. For example, 6 miles northwest of Lake Miluz in Bashkiria, they managed to double the amount of oil extracted using nuclear explosions, and when 15 years after the first blast, the well was drained again, they repeated the experiment and continued extraction. What about the crater at the Semipalatinsk test site? After the spring flood filled the crater, an artificial reservoir with a total capacity of 4.5 to 5.2 billion gallons was formed, which was named Chagan Lake. Right now, Kazakhstan has put Chagan on the list of areas most heavily affected by nuclear testing. The lake is still radioactive, and research is finally being done to figure out how dangerous it is for human health. Even though grass has started to grow around the lake over the years, the area is still pretty desolate. As for the radiation level in the lake, it's about 100 times higher than the acceptable levels for drinking water. The locals call the lake Atom Kol, meaning atomic lake. It's an unofficial name, of course, but it's very telling, so I used it in the video. By the way, remember I mentioned that only carp have settled in the lake? Well, they're even more radioactive than the surrounding water. That's because carp, being opportunistic animals, eat both insects and the grass around the lake, thus collecting contaminants. Despite this, the locals continue to catch the carp and eat them. Some, by the way, are said to grow over 3 feet long, although the authorities warn it's dangerous to your health. However, the main health problems for humans is not really connected to the carp, but to the soil dump zone surrounding the atomic lake, which stretches for a radius of 2 to 3 miles. Experts say that this zone should be seen as a significant potential source of secondary environmental pollution. And this pollution affects the water quality, vegetation, and even the air. It's no wonder that some locals call the lake dead. As for the water from the Chagan River, it's usually not used for drinking, but it serves as a vital water source for livestock across the region, and this is also a problem that could lead to troubling consequences. Contaminated water starts a chain reaction that leads to the buildup of heavy metals in the human body. Just because people eat meat from farm animals, and along with it, they unintentionally absorb all the harmful elements they've accumulated. That's how radiation works, and its consequences. You owe me a like. See you later.